Hello everyone, welcome to this video. My name is Sentinel-1. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to do oil spill detection in the Google Earth Engine platform using Sentinel-1 images. Let's go to the Earth Engine code editor environment using JavaScript. So, in the first step, you need to set the region of the interest. The region of the interest should be a place in which oil spill occurred in a single date. So to do this tutorial, you must know the exact location and you must know the exact date in which the oil spill occurred. For example, I know that in October 4, 2014, oil spill occurred in the Mediterranean Sea near to Cairo shoreline. So as you can see, this is the Cairo coastline or near Cairo coastline in the Mediterranean Sea and Port Said. As you can see here, I know that in 2014 an oil spill event occurred in this region. I don't know what the exact location is, but I know that in this region the oil spill occurred. So in the first step, I can set a region of interest through the rectangle drawing tools available here. For example, I'm selecting this region because I know that the oil spill occurred in a single date this region. So then, to have a focus on the study area, use map.center object, helping us to have focus on the region of the interest that is selected when the code is running. So in the next step, we need to call Sentinel-1 radar images. It is true that for the oil spill detection, you can use whether optical and radar images, no difference. But most of the time, radar images more preferable because the radar image can penetrate through the atmosphere even in the cloudy condition. That's a big limitation in the optical images that cannot penetrate through the cloudy situation. And most of the time over the seas and also over the open seas, we are facing with a heavy cloud cover, and that's why we have to use radar images to have a clear image about what's going on the water surface. So to call Sentinel-1 image into Earth Engine, it's very simple. There is a simple technique. First of all, make a new variable, same as the other tutorials, with any name you want. Sentinel-1 equals to, through the search places and dataset, you will be able to find Sentinel-1 product. Sentinel-1 ground range detection or GRD product, ground range detected product, is available. This is a SAR image in band C that is very useful for oil spill detection, land cover mapping, and also the other applications. So just import it into the code as an image collection. Sentinel-1 is one of the best radar images publicly available. Unfortunately, there is no the variety of radar images or public and free radar images is very low. Only for now we have Sentinel-1 and maybe ALOS Pulsar 1 for such period of time. Unfortunately, there is no other radar images publicly available. That's why in the most of applications we have to use Sentinel-1 with a 10-meter spatial resolution and also 6 days temporal frequency that is very useful to monitor different dynamics on the Earth's surface. So in the previous tutorials in my YouTube channel, I showed you before how to use Sentinel-1 for the flood detection, and you saw one of the application of Sentinel-1 and radar images. Now in this tutorial you can know about another application of radar images in one of the catastrophe that most of the time occurs over the seas, that is oil spill monitoring. So the Sentinel-1 imported as an image collection here. If you click on the data link, you can see all descriptions available for these products and the band and the period of time that this data set is available. So as you can see, various bands is available, but for Sentinel-1 images, only VV and VH polarization are available. VV and VH referring to the direction of electromagnetic radiation moving through the atmosphere. V referring to referring actually the vertical direction, and H referring the horizontal direction. For example, when satellite transmits radiations vertically, the first letter is V, and the and also the reflected value coming back, the reflected radiation that is coming back to the satellite is the second letter that is vertically. It means electromagnetic radiation moving from the sensor toward the target vertically and coming back vertically. But in the VH bands, meaning that the electromagnetic radiation moving from the satellite or the sensor toward the target vertically and coming back the reflected value horizontally. That is very, very useful, this kind of directions to highlighting different phenomena on the Earth's surface. These bands available in decibel format that is totally useful for the oil spill detection, and no need to convert them from the decibel to for example sigma naught or other radiometric criteria. So, and also there is no any scale and factor to apply, and also we want to use VV band because that band in the radar images which provided same polarization for the moving toward the target and coming back from the target to the sensor, these kind of bands provided more energy to detect the phenomena. Same polarization bands such as VV or HH most of the time or always or usually provided more energy to detect phenomena clearly and with a better clarity actually. So, and also compared to the but against the VH bands or cross polarization bands, as you can see, this is cross polarization and the first is copolarization. The cross polarization bands, because of the difference direction in the moving forward and coming back radiation, there is lower electromagnetic radiation, and we have some difficulties in detection of the oil spill in such kind of application. That's why I'm highly suggesting you for the oil spill detection use the copolarization bands such as VV or HH. So, and also now close the band for now and then assign the image collection, the imported image collection to Sentinel-1 variable. So when you want to working with radar images, that's very important to use some common filters such as filter date and filter bounds, and some specific and also some specific filters that only use for the Sentinel-1 radar images that I want to show you in this tutorial. So that first, filter date for now. I know that the oil spill event occurred in 2014. So I'm setting the start date 2014 and end date 2015. Now I have access to all Sentinel-1 images published during 2014. And then through the filter bounds, I want to bound all the Sentinel collections to the region of the interest that is selected by the rectangle. and here it is geometry. So in the next step, I'm gonna make another filter to find a specific date or select the specific day in which the oil spill occurred. I know that the oil spill occurred in the 2014 month, for example, October. So before that, let me to get a print first to see how many images available for this period of time. Print Sentinel-1 for the 2014 and the region of the interest. You can see in the right panel 62 elements or 62 images available for this period of time. But we want to filter these images only for 1 month, the October. So it's very simple to filter according to the temporal characteristic using calendar filter. Earth Engine filter calendar range is one of the most useful filters that related to the times used in the Earth Engine platform and helping us to filter out data according to a specific day or a specific month or a specific or single time actually. So the calendar range has 3 arguments: the start, end, and field. Field here is important because showing different attributes that we can filter the data based on. If you go to the docs, here find the calendar range. As you can see in the left panel, calendar range descriptions and data descriptions is available here. The start referring to the start the desired calendar field, and end the end of desired calendar field. But the field is very important. Field can be year, month, hour, minute, day of year, day of month, and day of week. That's very important. You can filter your data according to the various descriptions. So, for example here, I'm gonna filter the data only based on the month in the first step. My target month is October. So, October is month number 10, start and 8. When you want to find a single month, start and end date should be same here, and the field should be month. When you run the code in the image collection, right panel, only 21 elements available, and all of them related to the October. So as you can see in the data descriptions, you can find all the information related to this data. And I don't know the date is available with the date format or not, but in the band name you can see that all of the images for 2014 and month number 10, as you can see all of them for month number 10 from the day number 4 to the day number 29. So in the next step, I know that the oil spill occurred in the day number 4. So the May 4, 2014 is one of the dates in which the oil spill occurred. So then in the next step, making a new filter again based on the calendar range, but this time I'm gonna filter the data based on the day of the month. Back to the data description, and you can see one of the attributes is day of the month. The day number 4 is the day of the month or the target day in this part. Instead of field, we have day of month. The start day is day number 4 and the end day is number 4 again. Using this format, you can easily select a specific day or a specific month in your processing steps. Run the code again, and here you can see only 3 elements available for this period of time. That's very important, and you see that how we can filter our data according to the temporal characteristic and also the region of the interest. So in the next step, if you go to the data description here, there is an example code for Sentinel-1 images that's showing that when you are working with such kind of data, it's very important to use such kind of filters as list contains and also the instrument mode. So accordingly, we have to follow the guidelines available here and use the list contains and also instrument mode filters to find the most appropriate images during the processing steps. So now in the new line, make a new filter. Then the first filter is the list contains. We need to select those of images that in their property list containing transmitter-receiver polarization VV. It's very important because we want to work with VV bands. It's very important transmitter-receiver polarization including VV. So now as you can see, for each image we have a list of properties available here, and as you can see, transmitter-receiver polarization through the list contains should include the VV band. So that list contain transmitter, receiver. You can also copy and paste it. If writing is a little difficult, you can copy and paste it here. Should include the VV, just like that. So, and the next one is instrument mode, and as you can see, instrument mode is another property available here, and all existing elements should be equals to interferometric widths or IW. So again, another filter earth engine dot filter dot equal this time. It's very important the image in instrument mode in each image equals to interferometric mode. So type instrument mode equals to interferometric widths. So after that, we need to select one single band for the processor. As we talked about that previously, 3 bands available for each date: the incident angle value and also the vertical horizontal bands and vertical band. So my target of interest is working with VV band. Using dot select here, I can select the target band that here is VV. Run the code again, and now I'm sure that there is three images for this date and this region in which all of them, including transmitter-receiver polarization to VV, and also their instrument mode equal to interferometric widths, and all of them have VV bands. That's very important. So in the next step, this is an image collection, and we can do a visualization process to see that how these 3 images covering the region of interest. So just like that, using map.add layer, you will be able to visualize the imported image and filter it available here. The collection I want to show is Sentinel-1. To have access to all images, I need to convert them from a collection to a single image with 3 bands, each band showing 1 image for 1 region, using dots to bands. No need to clip it based on the region of interest, because I want to see that how these 3 images covering the region of interest. So, and then leave the visualization properties empty here, and the layer name should be Sentinel-1 or any other name you prefer, and also use the false at the end to avoid automatic visualization that highly reduces the speed of processing in the Earth Engine. Run the code, and after a few seconds, in the layers, we have Sentinel-1 images. If you go to the layer settings, 3 images available for May 4, 2014. You can visualize every image separately to see that how these images covering our region of interest. For example, here you can see that one of the images is out of our boundary, and also it's not very important to have this image. Finally, we can clip our image based on the rectangle or the region of interest selected. Go to the second image, do the enhancement process, and apply it again. Now you can see a part of region of interest covering by the second image. And what about the third one? Try for the third and click on apply, and you can see another region is covering by this image. So we can mosaic all these images, all the 3 existing images, because all of them related to a single day. So to do the mosaicing process, it's very simple to use .mosaic at the end of the code. .mosaic at the end of the code, helping you to mosaic all the images for a single images. But it is better to mosaic all those images with the same. As you can see here, there is another filter is about the orbit pass. Would be better to mosaic all the images with the same orbit pass, ascending or descending, to avoid some kind of errors that may occur in the further processing. So here, if you want to see that 3 existing image equals to descending or ascending situation, it's very simple. We can test it to see what's the condition for our data using .aggregate array. As you can see, by the aggregate array, I can ask the code, I can ask about the variable Sentinel-1 to see that the orbit properties pass is, for example, ascending or descending. Run the code. As you can see, all of them are ascending, and now we can mosaic all of them, because it's very important to have a same orbit pass in the mosaicing process, and when you want to merge all the existing images, it's very important to pay attention to this criteria. After mosaicing, now 3 image collections, the 1 image collections with 3 elements converted to a 1 image. And now here there is no need to dot 2 bands anymore in the code. And now remove the 2 bands and run the code, and 1 mosaic image is available for the region of the interest. So by 90% stretch, I can increase the contrast in the image. As you can see, the oil spill is clearly detectable in the image close to the port side. Using to transparency, you can see that the oil spill pattern is spread on the seawater. When the oil spill occurred over the seas, because of the smoothness layer, creating by the oil spill on the water, the intensity of reflection decreased a lot. And here, that's why you can see the oil spill region with the lower reflectance value compared to the other regions. And also the bright spots or the white spots you can see here related to the ships in this region. because the microwave electromagnetic radiation highly sensitive to the shape and structure of different phenomena, and surface roughness is very important. When surface roughness increases, for example, when we have a ship over a smooth layer over a smooth plane, such as a ship over the sea, you can see that ship showing with the higher brightness, meaning that reflecting higher microwave radiations. But the oil spill make the water surface smoother, and then reduces the amount of reflectance from the water surface. That's why we can see the oil spill darker compared to the other phenomena in our studies. So, as we don't need to the extra regions here, just I want to clip my image according to the region the oil spill occurred. It's very simple. Click on the geometry you drawed before and reduce the size of region of interest. That's very simple techniques. And when you clip the image and when you bounding your region of interest to the smaller regions, only according to the specific according to the border of the target of interest, helping you to have more speed of processing in the Earth engine in the next step. Now easily I can clip the image based on the new region like that, based on the geometry, and finally you can see the Sentinel-1 image created very fast. So as you can see, that image is ready. You can increase the contrast by different techniques. Now is better. So in this step, for now, oil spill detected. So through the inspector, you can check the values of the oil spill region in order to separate it from the other part of the sea surface. So if you click on this region, you can see that minus 25, the lowest values, referring to the oil spill, minus 25, minus 24, while the water surface is minus 18 and or minus 16. In order to see the range of values, and the range of values showing the actually the oil spill pattern, would be better to use the histogram. Histogram is a simple technique that helping you to know more about the range of the values for different phenomena in the image. So using the print called user interface chart image and histogram, chart image.histogram. Only 3 arguments needed here. One of them, Sentinel-1, no need to clip anymore here because we have an argument explaining the region of the interest. And the scale is very important. Although the scale of processing is the scale of this image should be 10, but most of the time, if you are working in the big area, you may face with the errors, and would be better to use 30 or 100 instead if you face with any errors related to the density of the pixels. So now run the code again, and histogram is available here, and as you can see, the histogram showing that the range of the values ranging from minus 33 to the positive 21. And definitely the lowest values, for example less than 20, should be equals to the oil spill event or the oil spill detected. So we can use the different threshold here to find the main regions covering the oil spill in our study area. It's very simple and easy to use technique. But before doing this, you can see that we have lots of speckle impact in the image. Speckle is an inherent characteristic in the radar images with salt and pepper pattern in the image that most of the time causing problem in their processing and calculations. Would be better to use some low pass filters to make the image smoother and reduce the roughness coming from the speckle uh, speckles available on the image. So in order to reduce the impact of speckle, we can use the low pass filter using focal mean or focal median. So to do this, make a new variable. This is dspeckle image. dspeckle image. The dspeckle equals to get Sentinel-1 image and then through that focal mean, you will be able to apply a low pass filter according to a specific radius and kernel type and unit to reduce the high frequencies coming from the speckle impact. The radius, for example, I set the radius to, for example, 30, and also the kernel type should be a square because the shape of the pixels is a square and the unit should be meter. When I'm smoothing image according to 30 meter square kernel structure, meaning that the image is smooth to reach to 30 meter spatial resolution, and definitely some of the spatial details is smaller than 30 meter removed from the image, but instead you can have one image smoother with the lower impacts of speckles. So because 30 meter still is good for the oil spill detection in our processing. So through the map.add layer, I will be able to visualize the dspeckle image. dspeckle image dot clip it based on the region of the interest or geometry and leave the visualization empty, and this time the layer name is Sentinel dspeckle and use the false at the end to avoid any further processing. So to avoid automatic visualization. So the meter is wrong, we need to change it to meters. Most of the time, if you read the errors showing in the right panel, same time you can solve the problem. So run the code again. Sentinel dspeckle image is created, and when I visualize it with 90% increase, you can see that the speckle impact clearly decreased in the image. So you can compare the after and before processing image. You can see that the smoothing effect, this is the high impact. In first, we had lots of speckle impact, and now after low pass filtering, you can see that image is smoothed and its spatial resolution decreased to the 30 meter, but still we can see the oil spill region clearly. That's very important things for the analysis because helping us to reduce the amount of faults that may occur in the further processing step. And then you can check the histogram after the speckle process using a print user interface dot chart image dot histogram. You will be able to see the histogram of the speckle image for the region of the interest or geometry with this time 30 meter, because after the speckle and after low pass filtering some details reduced and also spatial resolution reduced to 30 meter. That is still is good for the oil spill detection. And in the right panel, you can see there is a little change in our image. A histogram, a single mode histogram, converted to the multi-mode histogram. The first mode created after the speckle process, highlighting the pixels for the oil spill much better than before. And now I can find the appropriate the threshold for the oil spill much better than before. That's very important things, meaning that the speckle process helping us to separate the water from the oil spill much better than before. So, and now in this step, I can say that the range of those of values less than -20 could be a good threshold to separate the oil spill from the non-oil spill pixels. So let's try it. Use a new variable. The threshold for the oil spill equals to from the speckle image created before by the low pass filter. Select those of pixels less than -20, and then using map.addLayer, I can visualize the result. Visualize the threshold, clip it based on the region of interest, leave the visualization empty, and the name is oil spill threshold, oil spill, and use the false at the end. Run the code again, and here we have a binary image that's showing the oil spill region or the pixels with the and also the pixels with the value lower than -20. But still we have one problem. Lots of pixels available existing in the image that's showing the values less than 20. Maybe would be better to make a little change in the threshold. Those of pixels less than -22, and try it again to see. Now it's really better than before because lots of errors and noises removed after made a little change in the threshold. Because as you can see, we can say that the first mode from the right side just starting with the values less than -22 or even -23. Try it again. Oil spill. Now it's really better with the lower errors and that you can see in the image. So anyway, and there is another way to reduce the errors in the oil spill detection. For example, I'm gonna select -22 as a main threshold to separate the oil spill from the non-oil spills, but we can increase the intensity of low pass filters from 30 meter to 100 meter. And when you increase the intensity of low pass filter, definitely you can visualize the oil spill with the lower noises and with the less noises. As you can see, now it is really clearer and with the lower noises, and also we can use it as a final result. It depends on you which spatial resolution selected here and which spatial and which threshold value selected for, because this is an experimental process, and also it depends on how much the error rate and also error cap you have considered for your calculation. For example, as this is the clearer image, I want to select this as the final image for the further processing. Now I want to calculate the area of the oil spill in the next step. How we can calculate the area of selected region? As I mentioned it in the previous tutorial, in different tutorials, I showed you how we can calculate the area of a specific filter, a specific pixels in each images. It's very simple technique. In the first step, we need to remove the zero values from the image. So make a new variable as mask. We want to remove from threshold image those of pixels with value 0. Update mask with threshold. So now using map.add-layer, you will see that the mask layer that is clipped based on the threshold will have no zero value anymore. So this is the mask, and use the false at the end. So the mask image is created, but there is a problem. Must be an image. The mask threshold dot update. Oh, that clip based on the region of interest. Sorry, my mistake. So the mask image is created that's showing only the oil spill regions over the sea without zero values. So in the next step, I'm gonna calculate the area of each pixel using area image. The area equals to get the mask layer and then throw the multiply apply earth engine.image.pixel area. If you want to have area of each pixel with a square kilometer, because by default it is a square meter, divide the pixel area to 1 million. So it's a constant value helping you to convert from a square meter to a square kilometer. So now after calculate the area of each pixel, we want to get the sum of all pixel areas to get the total area for the selected region. So here make a new variable oil spill area equals to get the area image and then through the reduce region calculate the sum. The reducer equals to earth engine.reducer.sum. The sum of all pixels for the region of the interest. Region of interest is geometry, and scale here, because the spatial resolution reduced to 100 after filtering process, the scale should be 100 then. So, and here to have access to the main value after this processing, that values used, and to get the first item in this process that gets 0. To convert the final value to the number mathematically, use earth engine.number. Finally, print oil spill area in a square kilometer. Code is running. In the right panel, the final number 21 square kilometer, showing the area of the region covered by the oil spill in the, for example, October 2014 or October 4th 2014, that is calculated using Sentinel-1 image. And if you want to get export from, and also you can also make a vector layer for the selected region. That is very simple in the Earth engine. So make oil spill vector layer. Maybe if you want to the oil spill layer for the further processing in the GIS modeling, you can extract it or download it from the Earth engine and use it in the GIS processing system, in the ArcGIS Pro or any other geospatial software you are working. So here oil spill vector equals to, so now we have the mask layer that's showing the oil spill region, mask that reduce to vector. It's very simple. Reduce to vectors, helping us to convert this raster layer or grid structure to the shapefile. The only thing is matter is the geometry. Geometry equals to the geometry, and a scale should be equal to 100 because after processing the scale, after filtering process, the spatial resolution reduced to 100. So, and now use the map.add layer. I can show you the vector layer created for the oil spill. So it's very interesting things. So with the satellite view, I'm waiting for the vector layer created for the oil spill, and now I will show you how to download it in the Earth Engine platform. It's another easy task. Thanks to the Google Earth Engine platform, everything is ready to use without any complexity. You can write very interesting functions and get outputs. So export dot table to drive. Table to drive. I want to get export from a table here, table referring to a shapefile. So the collection or the tape file I want to get export is the oil spill vector layer, and the region and the description is the name of the output is, for example, oil spill for a specific date if you want, and then the file format equals to SHP. I want to get the shape file for the output, and that's important. And if you want to have output in a single folder, folder is another argument, equals to, for example, oil spill. Run the code and then go to the task, run the oil spill vector layer, and now we must wait until the process of saving in the Google Drive is over. And once the tab converted to the blue color, as you can see here, meaning that the process of saving is over, and then through the open in Drive, directly you will go to the folder in which oil spill data, oil spill, SHP, DBF, and SHX is available here. But unfortunately, I already had an oil spill folder, and now I can make a new folder as oil spill number 2 to show you the final results better. So run the code again. But this time the result is I must change the oil spill folder. Let me to cancel the saving process. This is the oil spill image. The new folder is oil spill number 2. Run the code again and run the output. I'm waiting for the saving process. After process of saving in the Google Drive is over, we can go to the Google Drive and see the final result easily. The previous time the process was correct, but because of some existing file in the oil spill folder, I thought that maybe it is a little confusing for you to understand about the results. And now this time I made a new folder, and in the new folder you can see that the oil spill number 2, all systematic files for the SHP files is available. You can select all of them by the right click and go to the download. As you can see, you can download all GIS layer partitions to collectively and use them in the GIS processing steps. I hope you like this tutorial. If you faced with any problems during your processing steps, the code example is available below this video in my YouTube channel and in the description box. Please check your code with mine, and if the problem still exists, put your comment in my YouTube channel. Thank you for your attention.